X Materials Processing is a small startup company at Innovation Park founded by Matt Woods in 2015. X Materials is designing a consumer-priced multi-metal 3D printer. Rather than using a single metal powder, their printer will be able to utilize stainless steel, Inconel, and a high copper alloy all at the same time. The advantage of this system is that it allows complex parts to be built in a single machine step. The drawback is that the excess powders, which are very expensive, cannot be reused once they are mixed during the printing process. In a single material printer, the waste can be sieved and reused easily. Our capstone team was tasked with separating the unused metal powder mixture left after printing into its base components so that the powders can be reused. We utilize a 2-conveyor magnet system to accomplish this. The design consists of a lower conveyor which transports the mixed material below an upper conveyor, which houses a magnet that attracts the stainless steel. The remaining powder mixture, consisting of Inconel and copper, is then submerged in liquid nitrogen to decrease its temperature below the Curie temperature of Inconel, so that it becomes susceptible to magnetism. Here it is, step by step. At the beginning of the process, the completely mixed powders are passed through a sieve to strain out any agglomerates or contaminants. The powder is deposited uniformly and thinly on the first conveyor belt. This belt carries the powder underneath a magnet mounted above the second, upper conveyor belt. The stainless steel experiences magnetic attraction and is pulled up onto the bottom of the second conveyor, leaving the Inconel and copper behind on the first conveyor. Wiper blades mounted on the second conveyor belt push the stainless steel out of the magnetic field, allowing it to drop into a collection pan. The remaining 2-powder mixture continues on the first conveyor and is then deposited into a second collection pan. The remaining Inconel and copper mixture is then submerged in liquid nitrogen at -196 Celsius. The Inconel, which is non-magnetic at room temperature, becomes magnetic at -112 Celsius, but the copper remains non-magnetic until even colder temperatures. Because liquid nitrogen's temperature is below the Curie temperature of Inconel but above that of copper, the Inconel will react to the magnetic field, while copper will not. Some magnets are then added to the mixture, and the Inconel is attracted to them. After the magnets are removed, only copper is left in the liquid nitrogen. The liquid evaporates, leaving behind pure copper. The Inconel powder coating the magnets warms up past its Curie temperature, where it loses its magnetic susceptibility. The powder can then be easily dislodged. This process can reliably separate a stainless steel, Inconel, and copper powder mixture.